Hello, workshop. Oh, hello, dear. Yes, I'm just doing a bit of dusting. Yes, I'm dusting my doors. I know, it's all that grinding. Dust gets in all the nooks and crannies. Okay, I'll have a cuppa later. There you go, Diana. You can go back up there. Hello and welcome to Tweed's Garage, where in this episode we're going to be doing some more work on the Bantam. I've been working on the Bantam, but we've been doing a few other things as well, going out collecting more family heirlooms to be seen maybe in later videos. But for the moment it's sort of work on the Bantam and little jobs around the workshop to try and tidy it up a bit, because it's always a mess in here, as you may have noticed. So what I'll do is I'll sort of take you around. The first thing I've done was made a new set of shelves above the lathe. You may have seen it in the older videos. There's a wooden board on the wall that had all the indexable tool holders on it and a few milling bits and bobs. But there wasn't really enough room and it was starting to sag a little bit. So we needed something a bit stronger and more of them. So I come up with a little solution. But as you can see, this is a what they call a, I've forgotten, hang on, it'll come to me, Marley garage. They're sort of called Marley garages over here. Don't know what they call them in the States. Sort of prefabs, that kind of thing. It's all made from concrete panels that slot together, and it's sort of held together with concrete posts interlocking with bolts and clamps like here that hold them to the upper posts, and then metal A-frames bolted to across it and to the top, and it makes quite a strong structure. But for putting shelves up, it's a nightmare, because the concrete panels are about yay thick and they have steel rods in them as well for reinforcement, so it's always a bit of a gamble when you drill through whether you hit a rod or whether you get through the concrete. They're not too bad to drill. As you can see, there's sort of raw plugs there. That's screwed to the wall. This is screwed to the wall. Yeah, so you can do it, but you're always guaranteed that when you're drilling, no matter how careful you are, you'll always blow a hole through the back onto the finished face on the outside. So my garage, my neighbour's garage, if you look, there's loads of little holes where raw plugs and screws have been stuck, and it sort of just popped out the back of the concrete panel. So you're a bit limited to what you can put on the walls, really, but I've come up with a cunning solution. You may have seen it before. Yeah, so yeah, come along and let's go and have a look. So here it is, the new improved workshop shelves. So I've gone from 1 to 3 shelves, retained the wooden shelf, used it at the top, and then the lower 2 shelves are made from, I had some leftover shelving uprights. These are these sort of clipped together shelving units. I was given a set that had the shelves robbed of it, and these were left, and I didn't know what to do with them. But these sort of folded steel profile sides are fairly strong. They might have a bit of a twist on them, but what I've done was doubled them up, used 2 of them together, and then along the bottom just cleaned the paint off and sort of run some tack welds down the middle to join 2 pieces together, so they wouldn't slide about, keep them secure. So that was these shelves, and they've worked out nice and strong. You can just tell by the weight on there. I mean, that's a set of sort of up to 30mm 3 Morse tapered drill, so that in itself weighs a bit. Yeah, and we've got sort of a clamp set over there for a milling machine, and collets and all sorts up there, so it's supporting a fair old weight. And the way I supported it on the wall was with these. This is the original shelf bracket that I made. It's just sort of a piece of sort of 2-inch angle welded at an angle to form a support for the shelf, and then with one hole drilled through it for a clearance hole on these clamping bolts for the concrete panels. And I had them on this one up here like that, so that would go in. The panels are secure. I mean, if you're not too sure, you can get a couple of mates to hold the panel whilst you undo the bolt, or put another bolt over the top, but this is pretty secure. So you just wind the bolts out, put your bracket on, put the bolt back in with the plate for the panels behind it, and then bolt it back to the wall. And then what I'd done down the bottom was welded a nut on the back and put an Allen bolt through it, and I use that as a jacking screw because when it's on that plate's away from the post that it's secured to, so you know, you've got the possibility of it tipping like that. So what I've done is put a jacking screw in the bottom. Once they were bolted there, just sort of do the bolt up until you get them plumb level, and then you leave it like that, and that won't go anywhere, you know, because all the weight's pushing on this bolt against the concrete. So that was the general idea. That's how I've done the single shelf. So this is just an expansion of that. So for this version, I made a bigger version of this with 3 pieces of angle welded for the shelves at the positions that I wanted them to, and then 2 long support brackets at the back, and measured and drilled for 2 of the fixing holes on the concrete up posts on the garage. And then also, like the shorter brackets, just to take a bit of strain off the bottom shelf, because it's lower, you know, it's about 10 inches lower than the fixing bolt there. With that weight on, you don't want it sort of trying to bend downwards like that. So like the Mark 1 shelf bracket, I welded a nut on the back down near the bottom, and then put jacking screws in the bottom of the shelf uprights. So same thing, done one side at a time, carefully took the nuts off, put it on, bolt it up, done the jacking screw at the bottom to level it all out, and then it's sort of made that these shelves drop in nice and tightly. There's a little end cap welded in here to stop the shelf coming this way, so they are just resting in there, but they're held quite tight. When those bolts were done up, it squeezed these shelves within the shelf brackets. And then up the top, it's just a wooden shelf, because there's not a lot of weight on that. That's just sort of tucked up on top of the angle iron on the top. And as you can see, that sort of works out quite well, and it's got a lot of rubbish off the bench, off the end of the mill. Yeah, also busy made this drill stand here for these new set of drills that I got. Yeah, it's a fairly heavy thing, but that's just sort of scraps that next door neighbour gets hold of occasionally, bits of old sort of refrigeration chassis units that are lying around going for scrap. They're a nice sort of decent gauge steel, and they would, you know, this in this profile, so I just sort of cut them to shape, welded 2 together, and then drilled the holes for the drills to go in. And I'll probably make another one so that I can tidy up. I don't know if you can see that on the camera. Get rid of this support plate with my milling cutters and drill chucks and that on the back of the milling table there, because that's always a nuisance when you've got a long job. You've got to unbolt it, take it off, you know, put it on the bench, carry everything over. So I'm going to make a stand for my milling collets as well, so that can go up that end, and it keeps it all nice and tidy. Yeah, bang tidy, as they say in Wales. So another piece of equipment to sort out on the electrical side was the brake light switch. Could have bought a new Chinese replica of it, but I thought we'd try and take it apart. and like the horn, it was riveted together. So just a case of drilling the rivets out and pulling it apart. And it was sort of quite gungy in there. All the old sort of fashioned pitch type of waterproofing was in there, so we sort of picked all that out and then gradually assembled it, took it all to pieces. It's all fairly simple, so it's basically just a sprung plunger that shorts out the two contacts inside the unit. So yeah, as you can see, it all come apart. Gave it a clean, cleaned all the contacts, and then gradually sort of reassembled it using sort of silicone grease where parts needed lubricating, and then sealing it up with modern silicone gasket. Checked that we had continuity, which we did, and then just reassembled the unit. I had some very small BA sort of electrical screws with nuts that were just the right size. So popped them in and screwed it all back together and popped it on the bike. And so we now have a working brake light. So to check the crank of the Bantam, I needed a truing jig. So I knocked this up, again out of bits of scrap. These are the same pieces of material I used for the drill stand for the big drills. Had 2 end bits left over, just sort of sandwiched them together, welded them back to back to give me a piece of C-section channel so it will rest on a bench like so, or you can stick it in a vise like this and just tighten up the front, keeps it up and out of the way, and a sort of nice height to work on. For the stands, they're just 2 pieces of again 2-inch angle iron with some end caps welded in the bottom with another bit of angle iron, and brought around the front to add a bit of support to the front of it. And then I put these in the milling machine, clamped them together, squared them up, turned them up the other way, and milled these faces flat, so it sat nice and flat on the bed. Bit jinky sort of doing that because you're sort of held down here in a vise. This is quite thin. I did have a bar clamped between the two to clamp it up, but even with all that done, it sort of chattered more than a sort of well-attended WI meeting. So anyway, so with that done, then I sort of put a couple of flange bearings at the top of this one with a little groove out of it to allow clearance for different crankshafts sitting in there. And then on the other side, I've got these 2 bearings. Oh, we'll get there in the end. These 2 bearings on a plate that can be moved up and down, moved up or down a bit. This is fine for the Bantam crank, but I might want to take a bit more out of this side to give me a bit more clearance, because not all crankshafts have identical diameter bearing journals each side, so it's just to allow for that difference. And then with plenty of space on there, gives you a chance to put the old magnetic clock stands on. And then these can be, you know, you can put these either side. I mean, I've just got 2. This one I've had for a long time. This is a copy of a Noga stand, a small one. Makes life easy. And then this is a genuine Noga stand, long reach one. Yeah, if you're ever thinking of, you know, thinking, oh, it's a bit pricey, but I do see them. This is a long arm one. Yeah, one of those tools. Regret not buying one sooner. You know, you can just put it anywhere, tighten it up within seconds, you know, move it around, put it on there, tighten it up, and it's rock solid firm. So good bit of kit, so I recommend that. But this is long enough as well to reach from one side to the other, so you don't even need 2 clocks. This just makes it a lot easier. So then you can rest the crank on here, turn it, and get your clock readings and go from there. So we'll have a little look. So first we put the crank on the stand and then put our clock on. And then bring that down to the bearing journal. Put a bit of preload on it. And then find our low spot and our high spot. Turn it gently, don't shake it around too much. Turn it round, so we get a high spot, which is just about there. And then we pop a mark on it. Okay, so with that done, move over to the other side. about there. And again, mark it. Okay, so when we turn the crank to the mark points, got one here and one here. So they're both in the same place. And then looking at the axis of where they are, they're almost opposite the crank pin that runs here. So what does that mean? Done you a drawing. So like Blue Peter, here's one I prepared earlier. So this is a basic sketch of your crankshafts of the flywheel, and this is your big end pin there. And what you're looking for is run out in two planes. You either get it where the flywheels, when they're pressed onto the crank pin, are not pushed on square, so are sort of riding outwards or inwards. So if it was like this, where the gap was bigger opposite the crank pin, you would have a high spot in line when you're looking down the crank pin and you're measuring your high spot. It would be sort of in line roughly with your crank pin when you look through the jig when you were truing it up. So you'd have a high spot here and a high spot here, which would mean that your flywheels were parted this way and the gap was bigger this side than it was at the other end of the crank pin. So what you needed to do, or we need to do, is sort of put it in a vise and gently squeeze it in to try and get it back in line. Or the other way it can be is that the gap's closed at the bottom and it's bigger at the top of near where the crank pin is. So again, when you clocked it, you'd find you'd have a low spot here and a low spot here if you're measuring from this way. Okay, so what you need to do then is you need to drive the flywheels apart at the opposite side of the crank pin. Okay, so the way you would do that is quite brutal. Make yourself a little wedge that you can tap in there and try and tap it straight. Okay, and if it's sort of this way or this way, what you'd normally find on the shaft is these high spots would be in line with each other, you know, on the shaft, that like there. So, you know, the other shaft, it would be exactly sort of roughly in the same place. So you know you're on the same plane. The trouble is I was getting, you know, you get one high spot here and one further around here, and then I'll try and knock it and it would move somewhere else. There just was sort of no logic to it. And then the other way you can get it out of line is if the two flywheels, when they're pushed onto the crank pin, aren't actually lined up with each other. So you get them slightly offset to each other. So rather than this, so if you imagine the crank pin is here, it'd be like this. This is exaggerated, of course, or the other way, like that. So then when you swung it round in your jig, you find your high spot would be here. If you were measuring from this way, or your high spot would be here if you're measuring from the other side. You know, if it was the other way, let's sort of keep it to measuring on one side. Then measuring this one, this would be a low spot. So that would suggest that we need to bump the crank back round. So the way you do that is quite brutal, but you sort of take it gently. So you'd rest one flywheel on a piece of wood, and then the other one would be like that, and then you'd bump this flywheel with a copper or brass mallet. Give it a tap, and then drop it back in and measure it again, and then just keep going and tapping it back round. And this is how they normally are. I think the Excelsior was fine this way, but was out this way. So I just managed, when I took it apart, put it back together, so I just managed to bump it back into line. So all was good. So it took about 2 sittings and 4 hours in total for Monkey Boy to realise that there was something more adrift with the crank assembly than just it being knocked out of true. Yeah, I sort of come to the conclusion that something was sort of seriously bent on it, and we needed to take the crank apart and replace bits. Trouble with the Bantam crank, because rather than it being a simple case of these being knocked out of true, I think what we had is there's a slight bend on one or both of the shafts in slightly different planes. So it doesn't, you know, it just didn't sort of correspond. You'd get one in. So what I managed to do was get the shafts within spec that way, but because they were now straight, although they were bent, I ended up with not too much run out on the outside edge of the flywheels. Managed to get them in, but I was getting a massive difference on the side of the flywheels, you know. And if you went to get the flywheels straight, then the shafts would go out. So it took a little while, but we finally got there and ordered the new shafts. So hopefully when we put it together, all the new bits and bobs, we won't have so much of a problem. We'll probably just have to sort of bump it back into line this way once we've pressed it together, and we should be up and running. So over to the press we go. So we've got the crank mounted in the hydraulic press with these 2 plates supporting the top flywheel, and then they're resting on these pressed rests that I made up out of thick wall box section steel tubing. So I just took some of this thick walled box section steel and cut a few pieces off, and then ground some flat stock out of some bits of leftover angle iron and welded them on the ends just to make a more solid bar for the press. I've got 2 there. So that's supporting everything there, and then what we're trying to do is push this crank pin down through this flywheel to release the lower flywheel down below. Hang on, let's move you down a bit so you can see down below here. So I'll sort of catch it here. Okay, so we've had an initial go just to see whether this would work, and it popped. So hopefully it'll move down. So close the valve and starts the pumping. Nicely lined up as best we can. Just square it up. Get the fingers out of the way. Ow. Not happy with that. There's a bit of flex going on there, but we can't avoid that. There we go. Take 2. stand out the way. Give it an enthusiastic pump. 2 tons. There we go, just up to 4 tons. Pressure it up again. There we go. 2.5 tons. Oh, see what we're doing. Release the pressure, panic. We're bending the crank conrod. Okay, let's see if we can rearrange. Okay, we're back with an even more sketchy setup, but at least the conrod's free this time. Don't worry folks, I've got a new one to replace this anyway, so no harm done. But, right, back up with the tonnage, fingers out the way. There we go. I think we've broken the back of it. Get my hand underneath, just support it. Yep, there we go. Up with the piston out of the way. There's that. Give you a bigger view. Boink. There we go. One side of the crank flywheel released. I'll leave that on there. I think all the bearings will fall out. There we go, I think we called it in time. So now we've got to push this crank pin out of this flywheel. Okay, valve shut. Centralise that as best we can. Fingers out of the way. Here we go. 2 tons, 3 tons, coming up to 4 tons. Give it a little rest. There we go, just over 4 tons. Keep it moving before it's time to think about it. No, I think we've bottomed out there. There we go, I just moved the bottom plate so the pin was above the hole. There we go, that's all it needed. Job's a good one. So there we go, crank partially disassembled. I've got the crank pin out, and yeah, quite glad we did actually. There's a lot of scoring running around it on the bearing surfaces. Quite sharp ridges there. Look like the bearings are sort of impacted or something on there. So that's that. Conrod, where it had been rubbing on the, where the crank's out of true, it's been throwing itself over to one side, and the conrod's been rubbing on the inside of the flywheels there. You can see it sort of made a bit of a groove there on it. So that's that. And as I said, I suspect these are bent, so I've got two new ones to go in. Hopefully true this crank assembly back up again. So they're to go in. So I've got to push these two out from the back, push them out from there, and then install the new ones. But I'm just going to measure the heights of everything, make a note of it before I press these new ones back in and press them in so everything's back to the correct length of these ones. Yeah, you can see the crank has been sort of throwing itself over. It's not too bad this side, but the conrod there, you can see it's been running against the side of the flywheel where everything was getting sort of pushed over. This crank's got a natural tendency to wander over to one side, and because they hadn't put any shims in, it allowed the crank to wander backwards and forwards across the cases. So I'm not too worried about these, not a lot we can do about these, but hopefully once it's all trued up, the conrod will stay in the middle anyway, won't wander around so much. Yeah, so there we go. Come out without putting up too much of a fight, nice and tight, but come out cleanly. So hopefully the new one will go back in. But in the meantime, I can measure these, push these out, and get the new ones back in again. Oh, other work on these, I succeeded in, one side had the rivet holes tapped and had used screws. The other side that had disappeared must have been riveted, and I didn't bother to do the other side, and then that come undone. So that still had the rivet holes. Can't remember which one it was now. Let me have a look. This one, because it's got the neater tapped holes. So what I had to do was, most of the holes were okay, but one of them still had some of the rivet in, and they were rock hard. I sort of broke a couple of end mills, and a carbide milling cutter wouldn't touch it, and tried the old trick with a sort of ground down masonry bit. That got a bit more of it out, but enough to run a tap down there to get a thread in there to put my screws in for when I reassemble it. So yeah, not much work left to do on these, he says. Okay, on to the next bit. So there you go, another little video to keep you entertained, sort of housekeeping around the workshop, little project there to tidy stuff up and try and make the work environment a little bit more organised, and progress on the Bantam. I think we've finally got to the bottom of all the damage caused by that. For those who haven't watched the earlier videos, I think we had a sort of broken rivet off of the stuffer plates on the crankshaft. Made its way up and got stuck between the piston and the cylinder head, and I think that just seized the engine up, and I think it caused the the drive chain to break and run itself through the back of the crankcases, hence the repair there. And also why I struggled trying to true the crank up, because I think there's some bending gone on the crankshaft as well. Yeah, it's just the laws of physics and inertia. You just can't beat it. You know, it's going to cause problems. But with the new shafts that I've got to go on it, hopefully we'll get it all back together and it'll be running a lot truer. I'm not going to say it's perfect, it is a Bantam, but a lot truer than it was. And yeah, we'll be able to build it back up again. Okay, so yeah, there you go. Hope you enjoyed it. I've got to go and buff my candlesticks, and I'll see you next time. All right? Oh, if you like it, give us a like, and if you want to see more, subscribe, because when I'm feeling, what's the word? Inspired, I'll do another one. Okay? Cheerio. Right, buffing time. Hello and welcome to Tweed's Garage, where in this episode we're going to talk about with three shelf he says. I thought I'd put a jacking bolt in. For the Bantam crank. How did I do it before?